So when it comes to sum operators, you have a choice about whether to do them element-wise or as a matrix operation. Now, for some of you, that you're always going to want to do things element-wise. Matrix multiplication is a very specific thing. It's a mathematical operator. It's a way of multiplying two matrices together. It requires your matrices to be a certain size. If you've done linear algebra courses, you'll have come across it. If you haven't, don't worry about it. But just be aware that when you try and multiply two matrices together in MATLAB, by default, it's going to try and do matrix multiplication on them. So if you actually want to multiply all the elements together, the first one multiplied by the first one of the other one, the second one multiplied by the second one of the other one, you need to tell MATLAB that you want to do that element-wise. And that's where you put this dot symbol before the multiplication. So here's an example. And here's an example where we're defining a matrix with multiple dimensions. So I'm creating something called my matrix. I'm giving it 1, 2, 3, which we know gives it the row 1, 2, 3. Then I have a semicolon, which tells MATLAB that I want to be on the next line. And then I'm having 4, 5, 6. So that's created a two-dimensional matrix containing 1, 2, 3, 4, 5, 6. Now, just as a quiz, if I was to do size on my matrix, what would the result be? We have one person saying 2 by 3. Any advances on 2 by 3? Everyone happy with 2 by 3? Great. So yes, that's correct. It would be 2 down, 3 across, so it's going to return 2, 3 if we do the size on my matrix. So I'm going to define another matrix that's the same size with different numbers in it. My second matrix equals 6, 5, 4, new row, 3, 2, 1. Check the values of my second matrix. Notice I didn't put semicolons on the end of these lines, which is why I'm seeing the results printed on the screen. I can do my matrix plus my second matrix, and it's going to add all the elements one by one. Addition is by default element-wise. But if I try and do my matrix multiplied by my second matrix, it's going to complain. It's going to complain and give this error that the inner matrix dimensions must agree, which will make sense if you're into linear algebra and won't make sense if you're not. But basically what it's saying is that these matrices are not compatible with matrix multiplication. And what we actually want to do is multiply the elements one by one, do this multiplication element-wise, and so you put a dot before the multiplication symbol here, do my matrix dot multiply my second matrix, and it will element-wise multiply them together. So now we have 1 multiplied by 6 is 6. 4 multiplied by 3 is 12. 2 multiplied by 5 is 10, etc. So every element in the same position multiplied by the element in the same position of the other matrix stored in our in the corresponding position in our output. Sometimes you'll see people use disp in their code. It's very similar to typing the variable without a semicolon at the end. So here you'll notice I've typed answer and I've hit enter. It's shown me answer on the screen. You can use that at any point to check the contents of the variable. If you want to be more clear in your code that you're deliberately displaying something to the screen and you've not just forgotten the semicolon, you can use disp, and then it will display the contents of your variable to the screen. Just the contents. It won't give you this and stuff. So it's a neat way of displaying the contents to the screen. You'll find people use it while they're debugging their code or just to report that the final result from your code to the screen. So disp is a great way of displaying the contents of a variable. OK, so we're going to make liberal use of the fprintf command to show text on the screen. So here we're going to show you how you can do it, because it's more than just that. There are some advanced things you can do with this print command, which we will use to substitute in certain variables while we're printing them. So here I'm defining a variable, number of days equal to be 3. Remember, that's going to be a 1 by 1 matrix that contains the number 3. I'm defining another variable, and this is the first time we've seen a string variable. If you hear me say string, I'm meaning it's words, it's text, it's characters on the screen. String is computer science language for words. So if I'm defining a string called name of instructor and setting its variable equal to Simon, I do it like this. You know this is a string because it's in single quotes. Be aware of the single quote we used at the end to take the transpose, and the single quote is the same single quote we're using here. The only difference is there's one at the start and one at the end, and there's some text in between, so MATLAB knows we're talking about creating a string. So the first two lines create two variables, one of which is a number, one of which is some text. Now on the next line, what I want to do is I want to print some text to the screen. I want to print, and when I say print, I'm not meaning with a printer, I'm meaning display it to the screen below the command. And you'll use this a lot when you've written a big script to keep whoever's running your script up to date with what's going on. So you type f, print f, and if you've written some C, you'll recognize some of this. Then in quotes, I put what I want to print to the screen. And what I want to print is, we are learning MATLAB with some string over some number of days. So you'll notice there's this strange %s and %d in our code. And what that tells MATLAB is that I'm going to substitute some variable in there. So we are learning MATLAB with some string over some number of days. And then what variables do we want to substitute in there? Well, we want to substitute in first this name of instructor variable, and second this number of days variable. Note the order of these are important, that the one you'd list first will be the one substituted into the first place. The second one will be substituted into the second place. So I'm saying that I have %s substituting in some string, %d substituting in some number, specifically an integer number in this case. And you see some of the other examples at the bottom. There's a bunch of them. I'm not going to go into all of them, but you'll use %s and %d quite a lot. So the reason we've used %s for one of them and %d for the other is because one is some text and the other is a number. And we want to substitute in some text, and then we want to substitute in a number. So when you hit enter on the end of that print statement, you should see we are learning MATLAB with Simon over 3 days. Because what MATLAB has done is it's typed we are learning MATLAB with some string and substituted in that name of instructor variable, which has the text Simon in it, and then it's typed over some number of days and substituted in the number of days variable that we told it to substitute in. Now you'll notice when we run that the start of our line, our nice arrows at the start of our line, have been glued onto the end of our print statement and look a bit ugly. So what's happened here is that we've got no new line character. It's printed the text to the screen, but it's not printed a new line afterwards. So to tidy that up, you can do the same command, but as a very last thing, do \n, which is the new line character. And then if you hit enter, you should see we are learning MATLAB with Simon over 3 days. It'll start a new line, and then our arrows for our next line of code will be on a separate line ready to go. It looks less messy, so it'd be good to get into the habit of whenever you're doing a print statement to end it with a \n. You can also use \t, which we'll make use of when we're creating tab delimited documents, but for now just worry about \n. Okay, so another thing that's very useful is that you can glue matrices together. You can concatenate matrices. There's a few different ways of doing this, and I'll first show you the cat function. So if I have one matrix that contains the numbers 0 to 3 and another matrix that contains the numbers 4 to 7, I can run cat, open some brackets, 1, comma, my matrix, comma, my other matrix. And the first number is actually telling us in what dimension I want to concatenate these things together. So I want to concatenate them together in dimension 1, which is down the screen, and therefore it will glue the first matrix, 0, 1, 2, 3, above the second matrix, 4, 5, 6, 7, and we end up with this two-dimensional matrix where they've been stuck together in the first dimension. The alternative is to do cat 2, my matrix, my other matrix, and it will stick them together in the second dimension. So then we will have all the numbers 0 to 7 listed in one long list as they have been concatenated horizontally rather than vertically. So this is the way of doing this with a function. What I find myself doing most often is using this square bracket notation with commas and semicolons to do exactly the same thing. So in MATLAB, rather than using the cat command, you can actually type my matrix, comma, my other matrix, and it will put all the elements of the first matrix and then glue them to all the elements of the second matrix on the same row. Remember, comma means the next element of the same row, and the semicolon means that I want to go on to the next row. So if I want to glue them vertically, the same way as doing this command up here, I can do it this way using my matrix, semicolon, my other matrix, and it will put the first matrix on one row and then the second matrix on another row. So this I tend to find is more simple and easy to understand than using cat and defining dimensions. Notice I've not defined any variables. There's no equal signs in my statement, so the answer variable is containing the results of my function. The find command we're going to make some use of in a moment. What find does is tell me all the elements of my matrix that are non-zero. So it gives me the index of all the elements in my matrix that aren't 0. Now you'll notice that these indexes are one-dimensional. So that's definitely something you need to be aware of in MATLAB, that even if you have a two-dimensional matrix, you can refer to every element of it with a single number. So what it's done here is it's said that every element, 1 to 8, is non-zero apart from the first one. So 1, 2, 3, 4, 5, 6, 7, 8. They're all non-zero apart from the first one. Let me show you one better example of that. So if I have my matrix equals, perhaps we have a 1 and then a 0 and then a 1, and then we might have 0, 0, 1. It's defined my matrix, it's arrived here. I can then do find my matrix, and you'll see that, let's pop open. I'm just going to show you that if you double click on a variable here, it'll actually open it up and show you its contents. So it's telling me the elements at index 1, 5, and 6 are all non-zero. Now what that means, we can now figure out how MATLAB is counting our elements. It says this is index 1, this is index 2, this is index 3, this is index 4, this is index 5, which is also non-zero, and this is index 6, which is also non-zero. So you may want to refer to these as 1, 1, 1, 2. Sorry. We always go down and then across. So this would be, you may want to refer to this as 1, 1, 2, 1. This would be 1 down and 2 across, so 1, 2. But be aware that MATLAB also has these indexes that are just single numbers where it counts every element in the matrix as 1, 2, 3, 4, 5, 6. So there's multiple ways of referring to elements in a matrix. Normally when you personally are changing individual elements, it's easier to think of it as down and then across. However, sometimes we're going to use this find command, combine it with other commands to update certain things, and you'll find it more useful then. But just be aware that these indexes with single numbers in two-dimensional matrices count down each row first. Okay. So this is giving you 2, 3, 4, 5, 6, 7, 8 because the first element, the number 1, is 0. Then every other element, 2, 3, 4, 5, 6, 7, 8, are all non-zero. So find will tell you all the non-zero elements in a matrix. Okay, so we've seen the size command. There is another command that's useful, which is length. Be careful when using length. What it does is it tells you the size of the largest side of your matrix. So if you have a long list that's just a row vector or a column vector and you want to know how many elements are in it, you can use length just to tell you how many elements are in it. If you have a matrix like this, which is 2 down and 4 across, the length is going to tell you that the largest dimension is 4. So it will always give you the largest dimension. People tend to use length when they're working with one-dimensional data. If you're working with two-dimensional data, then you should really worry about, you should use size and make sure you're picking the right dimension. But length is a shorthand way of getting just the largest length. So be aware of your answer variable and when it's updating, because you can fall into traps like this. I defined my matrix, and I have the ANS variable set to my concatenated matrix. I then check the length of my variable, the length of my ANS variable, and it's telling me it's 4 long because the largest dimension is 4. I then check size of ANS, and I was expecting to get 4 back, but I'm getting 1, 1 back. Can everyone see why I'm getting 1, 1 back there? Some shaking, any nodding? So the reason that this is returning 1, 1 rather than the 4 that we might expect is because the ANS variable has been updated in the line before. When I did length of ANS, what it did was it set a variable called ANS equal to 4. So now this ANS that we set up here has been erased. So ANS is no longer this matrix. At this point in the code, ANS is equal to 4. So when we do the size of the number 4, it's a 1-by-1 matrix, because all numbers in MATLAB are stored as 1-by-1 matrices. So if we actually wanted to take the size of our concatenated matrix, we might want to do something like this, the size of my matrix glued onto my other matrix, and then check that, and that will have the 2-by-4 that we're expecting. The alternative is, rather than using the answer variable in each one of these lines, what we should really be doing is saying x is equal to my matrix glued to my other matrix, and then checking the length of x and checking the size of x, and then you'll find it works fine. So this is a sort of warning lesson to not use the answer variable as part of your code. It shouldn't be a variable that you're using when you're developing, really. It's just a way of checking what the result of your last function was. Okay, so lots of things work on matrices. Specifically, they tend to work by default on columns. So if I define a matrix called my big matrix and set it equal to those numbers, remember you would do that by having a square bracket and doing 0, 1, 2, 3, semicolon, 4, 5, 6, 7. Close your square brackets, maybe a semicolon if you don't want to see the output, and then you will have a variable called my big matrix defined. If we take the max of my big matrix using this max function, you may expect it to return a single number, perhaps the largest element of our matrix, but what MATLAB does is it works column-wise and tells us the maximum element of each column. So be aware that many functions in MATLAB work on a column-wise manner. So the max of my big matrix is going to be 4, because the top of the biggest element in the first column is 4, 5, because the biggest element in the second column is 5, etc., etc. The same for min. It's going to take the minimum element of each column, and we see 0, 1, 2, 3. Even sum, the sum command, is going to take the sum of each column. So the first element of the sum is going to be 0 plus 4, which is 0, 1 plus 5 is 6, 2 plus 6 is 8, etc., etc. So max, min, and sum all work column-wise in your data. This is super useful if you have multiple replicates, you're trying to calculate the average of your replicates, if you have long time courses where you want to do something for every time point, and you have them, you have your time going from left to right, and you have your data going down the page. This lets you easily calculate averages and sums of all your data points for every single time point automatically. Even the plot command works by default going down columns. So if you type plot and then in brackets put my big matrix, you should see 4 lines plotted. And what those lines are is they are the line from 0 to 4, then the line from 1 to 5, from 1 to 5, from 2 to 6, and from 3 to 7. And so it's automatically plotted each line column-wise. And if you had more data points, you would see more interesting lines. But be aware that even the plot command works column-wise, plotting a line for each column in your matrix.